All right, and welcome back to this part of the session. On this part, we're going to be talking about framing walls, and it's basically just a quick rundown on refresher on how to frame walls, and it's a great tutorial.
Let's do a quick review of our wall parts using our models. So we have plates, they run horizontal. This is my bottom plate, this is my top plate. On top of my top plate, I have a cap plate. Both of these together, we would call a double top plate. On each end, I have a vertical stud. This is my end stud. This is my end stud. I have all of these common studs in between, and they're on regular intervals we will call layout. Your layout could be 24 on center, 16 on center, or 12 on center. Moving on to our rough openings.
Having said that, normally we frame 16 on center, and when I'm doing a calculation for materials for estimating, I will calculate them at 12 inch. So I've got extra lumber because you always want extra lumber on hand um, so that you don't delay your project.
We have a door rough opening, and on the very top, I have my header. It works like a bridge. It carries the weight down through my jacks to my bottom plate. I have a jack on either end or either side of my rough opening. I have a king stud. That's my last full stud that is connected to my rough opening. And my cripple studs fall on layout with my common studs. These are partial studs that land every 24 inches on this wall. On my window, I have the same part.
So the reason why he's got those is if you calculated his distance between studs, that the drywall lands on something to fasten to.
I have my header that carries my weight to my jack studs. My jack studs carry the weight down to my bottom plate. My king studs are the very outside parts of my rough opening, and they are my last full vertical stud that is related to that rough opening. My cripple stud carries the load from my double top plate down to my header, and then I have my sill, which is my bottom horizontal piece, and I have a cripple stud on layout that follows this upper layout down here.
So
I
it's
have
also
one thing
acting
here
as a
to point out
support.
on this wall that might be a little confusing. On this side, you see that I have one king stud, it's a full stud. On this side, I have what looks like two king studs. What's really happening here is that I'm following my layout. I have 24 on center, so I have common stud, 24 on center, common stud, cripple stud, 24 on center, and then my layout falls right here, which is outside of this king stud. So we're going to put this stud in. Our layout is very important that we don't deviate from it. So even if it's next to this full king stud, we still put it in. Have you ever been to the big box store or a lumber yard looking at lumber, and right next to the 8-foot or 96-inch studs, you see this really funny stud length? It's 92 and 5/8. Those are called pre-cut studs. You might wonder what they're for. They're for speed when we're creating 8-foot walls. Remember, we have other parts other than studs in those walls, and as we layer those materials, we're adding height. So 92 and 5/8 plus our other parts give us a finished wall height of 8 feet. Let's take a look at our presentation and our model and see how that works. What I have here is all of my parts from the top of the wall to the bottom. That's our bottom plate, our stud, and our double top plate. And on our presentation, you can see a sort of condensed version of this, an illustration. You see the break lines in there as well. Those break lines help us to squeeze this whole arrangement down to fit into our slide. You'll see those break lines in a lot of print reading, a very common symbol used. So what you have there is your cap plate, which is 1.5 inches. You have your top plate, which is 1.5 inches. Together they make a 3-inch thickness. You then add your 92 and 5/8 studs to that, and then you add a bottom plate of 1.5 inches. That would be 4.5 inches plus your 92 and 5/8. You end up with a total length from the top of this wall to the bottom of 97 and 1/8. Still seems like a weird number, but what we have to add to that is the thickness of your drywall right? That's a half an inch. So you can subtract from that 97 and 1/8 a half of an inch. You end up with 96 and 5/8. What is the purpose of that extra 5/8? That's the question I always get. What we're doing in an 8-foot wall is we're running our drywall in 4-foot sections. Once we add our ceiling thickness of drywall in, we add our wall thickness in of 48 inches under that, and then another 48 inches. What that 5/8 does at the bottom is gives us room to jack that drywall up for a tight seam right here in the middle of the wall. So the magic of a 92 and 5/8 stud is that it saves us time. We don't have to make any cuts to our studs. They're all exactly the same length.
Or in our case, where we're going to be talking about a legal duplex in a basement, first of all, he didn't mention about needing a gasket. So if you're on concrete, for example, you're in a basement and it's going to be, these walls are going to be built on the floor of a basement, that needs a gasket underneath the plate to separate from the concrete, the wood from the concrete. Also, you do not want that drywall right down to the ground, so that gapping is necessary in a basement as well. And I will estimate all my lumber in a basement, if it's below 8 feet, to use studs anyway. It's going to be less expensive than buying a full 2x4 8. And so studs are quite common in a duplex.
And if we put this wall together with our double top plate and a single bottom plate, we end up with a finished dimension of 8 feet from the inside of the ceiling drywall to the floor deck. Hi, sorry for the interruption. I had a quick message for you. We offer a lot of other lessons at our learning portal, which is tradeskillsu.com. If you're a teacher and you found us here, we have a ton of other resources to help you with your students teach them construction in a digital environment. You can find those at teachconstruction.org. Once again, thanks for watching. Let's get back to the video. Pre-cut studs are also available in a couple other sizes. So a 9-foot wall would require a pre-cut stud of 104 and 5/8 inches. That 5/8 at the bottom works the same for that 9-foot wall. It's clearance to raise that drywall up for a nice seam. A 10-foot wall can be made with pre-cut studs of 116 and 5/8 inches. All of these different pre-cut stud lengths leave us with that 5/8 at the bottom of the floor to jack up that drywall to make a nice tight seam. Remember, we're going from an unfinished floor deck or your subfloor. That 5/8 will be easily taken up by any flooring or finished flooring material that'll get added later in the project. Hello and welcome to another trades training video. I'm Joe Carswell, and this lesson is one in a series. In this lesson, we're going to cover wall framing connections. Let's get right into it. So let me set this up. In this lesson, we are going to be using some models and some scaled lumber. All of this will help me illustrate this in camera for you. We're talking about large walls, a large building, and this scaled lumber is 25% of actual size. It means we can get a lot more squeezed into this frame. And this represents a 2x6 board. It's probably 8 feet long, this particular one. And you'll see these even in, we have a model of a small building over here. That'll come into the video as well. Let's start wall connections off by talking about corners. When we have wall panels, which I've got a couple here modeled, we need to make corner connections. We can build wall panels all day, but we have to connect them. So we'll bring our wall panels together in a 90-degree corner, happens all the time. We have 3 things to consider when connecting these walls in a corner. One is going to be at the bottom. We need to make this connection here. That's the easy part. Our bottom plates are easily connected to a concrete slab using bolts. That's the common way to do it. Or if it's a wood deck, we will nail.
We won't use bolts. For the most part, when we're connecting a bottom plate to a concrete floor, we'll use a ram set or shots. And again, keep in mind that there should be a gasket under there when it's coming down to a concrete floor.
nail this down frequently. So the bottom connection is always sturdy based on this idea of platform framing. We're always connecting these to a deck. The next thing to worry about is this top connection. So we have no really good way to connect these walls at the top corner the way that they are. We have to add something. We're going to use a double top plate to make this happen. I want to show you that, but let me go ahead and clamp these walls in place so I'm not having to hold them. Before we get into this top connection, there's a couple of terms I need to go over to understand how this works. When you bring two walls together, you're always going to have what's called a through wall, which is this one, and a butt wall. Your through wall is going to carry through this wall width to the outside of it, and then you're going to have a butt wall. The butt wall carries directly into your through wall. You have to identify those to then consider how to connect your top plates. So once you've figured out which is your through wall and your butt wall, you're going to start with your cap plate on your butt wall. This cap plate makes this a double top plate. It will extend over our through wall and carry to the outside of it. So what we've done here is created this overlap, which we can then connect above here to make a solid connection.
So in our basement apartment that we're going to be talking about, we usually, when we're on site, first thing we do is we'll shoot a laser line down the one side of where that wall is going to be going and determine where the front of that plate is going to be. And we will put this top plate on first and fasten it right to the ceiling or the ceiling joist. And the bottom plate, same thing. We'll put it either in place if we don't have enough room. But if you put that top plate in first, you can actually build this wall on the floor and then pick it right up and put it in place, because that inch and a half, that spacing of an inch and a half of that top plate is going to allow you to lift that wall right up and place it right where you need it to be.
Here, that plus a cap plate filled in on this side will level out this whole area. We can then build on top of it, add another.
Not to mention, putting this in ahead of time allows you to connect to the joists, ceiling joists that are running in your basement. And when you do put your wall up, you'll have no problem pinning this up into that 2x4 plate that you placed ahead of time.
Floor deck, a second story, a roof, whatever. So let's do a quick review of this again. It's really important. You're going to start with a through wall that carries through to the outside corner. You're going to have a butt wall that dead ends into that through wall. You're going to take a cap plate on the butt wall that extends or overlaps over your through wall. That's where we'll make this connection of these two walls. We'll then add a cap plate to level out our through wall all the way around. So that takes care of the bottom and top connections. Let's talk about what happens in the middle. I've got some mock-ups for that. Hi, sorry for the interruption. I had a quick message for you. First of all, thanks for tuning in to our Corners and Connections lesson. We offer a lot of other lessons at our learning portal, which is tradeskillsu.com. If you're a teacher and you found us here, we have a ton of other resources to help you with your students teach them construction in a digital environment. You can find those at teachconstruction.org. Once again, thanks for watching. Let's get back to the video.
That's a free little plug for this fella.
These examples
and his videos
are
his
sort of cutaways or details of what a framed or two frame walls would look like as they come together. What you see here is what happens when you bring a butt wall into a through wall. And you're seeing it from above here. It's basically a detail or a cutaway. The outside corners here, as you can see, you have plenty of material to fasten to. And the big concern about the inside of the wall here is we need surfaces to fasten materials to. There's materials that have to happen here later, whether it's drywall or OSB for sheathing on the outside. We have to always consider that nailing surface. Never a problem on the outside of the corner. Have plenty of surface here and here to fasten to. The problem comes in on the inside here. And even On the inside of this wall, we have no problem. But look what happens over here. So I've got some materials here I'll lay in place. Perfect surface to connect to, fasten, no problem. Look what happens over here. I've got nothing to fasten my materials to. This is a consideration we have to make for every inside corner. So we have to add something in here to fasten our materials. As you can see, this is begging for something to connect to here. So we need to add parts. So here we have a mock-up of a corner connection with a nailer added. And this goes by different names. You might hear it called a 3-stud corner. Basically, it has a board that's turned sideways in the through wall that extends out. And what this does is create this inside surface to nail to. So if we have our drywall here, we also have a space or surface on this side to fasten our drywall to as well. So this corner becomes successful when other trades need to come in and add materials.
So you're getting the gist of this. This lumber is basically to pin drywall, and for electricians to run their wires through that you don't see them, and their plumbers the same thing. But turning it this way is going to allow you to, if you had to insulate this wall, let's say this was an exterior wall. If this was an exterior wall, first of all, you need an airspace in behind. So this 2x4 bottom plate, if you're using a 2x4 plate, will be pulled out from the wall at least 1.5 inches for airspace in behind, so that the lumber is also not touching the walls as well. And you may want to put a barrier on the concrete wall itself to separate for moisture and condensation. As well, is turning this 2x4 sideways is going to allow you that when you put your insulation in here, you can tuck it in behind. If this 2x4 was the other way, it would block it, and you would end up with a cold spot on this wall, of this exterior wall. The other thing is you end up with a lot of cuts when you're in a basement, and with those cuts, instead of throwing them all out, you can use them as these blocks, pretty much the same size as what's being used here, all the way up on this stud that's beside it, in order to pin this drywall to, so that your wasted lumber is no longer wasted lumber. It's getting used in this application.
It's really important that this part doesn't get left out. So this brings up an important point about corners and how framing is evolving. What we have here is, instead of placing this board like a stud and in the direction of all the other studs, if you turn it sideways, you're creating a void in here in the wall that you can access from the inside. The reality of framing is that you're going to sheathe this outside surface here when you drive the house in. The insulation doesn't come in until later. So now we have a place where we can access all the way into the corner here, and we can insulate it. That's going to create an energy efficient corner. And that's another name you might hear this called, a California corner, an energy efficient corner. So just by turning that nailer sideways, we've provided that access that's really important later on. So I talked about this stud being turned sideways in this through wall. Let's look at this other one and see what it used to look like when we built this. So here you have, this is an old school method of making a corner. You might hear this called a 4-stud corner. They would have counted them 1, 2, 3, 4 studs. What this was an attempt to push this stud out to make this nailing surface on the inside. And to do that, they would use blocking here. This would fill in or space out 1.5 inches and push this stud out so that it would create this nailing surface on the inside. As you can see, these two, they accomplish the same thing on the inside. You have nailing surface on both sides of the inside corner, but you've done it here with less material. And here's the real problem with this particular arrangement, is that when I have my materials like my sheathing on the outside, we've dried the house in, I have now created a space in the top here that I can no longer insulate. I have no more access to it. What this creates is energy loss in the house at every corner. So not only are we wasting materials, but we've also created cold spots or drafts in the house. We're wasting energy. That is no longer an option, especially in some code. Energy code does not even allow this kind of corner. You'll see it in framing. I see it even being done today, but this is sort of an outdated way to frame. This becomes a much more efficient way for cost, materials, and energy. So this example creates a less expensive, more energy efficient example of a corner connection. We can go even further with that. And if we go back to our original model here, we can add what's called a drywall clip to this configuration, say 3 clips that would travel, instead of this nailer, would be connected just on the inside of our butt wall here. And those drywall clips will catch the edge of that material, create a surface to fasten them to, and we can finish out that space. The benefit.
It's a great idea with those clips, and you learn something new every day. But the idea of grabbing your wasted lumber, your scabs, and putting them to use, in my opinion, is the way to go, because you're still going to end up with the gapping in behind that you can insulate if it's an exterior wall, but it's also putting to use all this extra wasted lumber that you've had to cut.
Benefits of this arrangement with the clips is not only we are saving money by not having to spend it on lumber, we're also creating more space in here that we can insulate. So even this 2x4 nailer here is taking up space, valuable space that can be insulated. So this becomes, as far as energy and cost savings, becomes an even better corner design. Buildings are not all exterior walls and corners. There's other connections we need to make. Mainly when you're talking about interior walls, a lot of those need to connect to our exterior walls. Those will be made with a sort of a perpendicular connection or a T connection. So this is the kind of situation you'll see where you have an exterior wall and you have an interior wall that's going to come into it or butt into it. This consideration, we need to do some different things here. Same issues we have to connect the bottom, and we have to connect the top, and we have to deal with the center or the middle part here. The bottom connection, just like our corners, will be made to the existing deck or slab, no problem there. The top connection, we will do similar to our corner. We will use a cap plate to extend over from our interior partition over this exterior wall, and then we can use another cap plate here to fill in the gaps and level all this out.
So again, if you're in a basement or you're remodeling or renovating a home and there's no drywall on the ceiling. So let's say there's no drywall on the ceiling and this is actually a joist coming through, and you've got nowhere to pin this 2x4 plate to because you're in between two joists. You're going to end up having to support or bridge in between the joists in order to pin this 2x4 top plate into place in order to tie this wall into place. So bear in mind that this top plate, to put it in ahead of time prior to building your wall, does help speed things up by building the wall on the ground if you're in a basement, and just lifting it up and putting it into place, because this top plate is going to be what you're going to be able to pin to, as well as fasten into this wall that he's talking about right now.
So that works just fine. Now we need to deal with what happens in this stud area in here. So let me get this out of the way so we can see a little more of what's going on. What I have here is nothing happening. We need nailing surface just like with our corners. So we're going to put a board in and turn it sideways just like with our energy efficient or 3-stud corner. And this board will be wider than our partition wall. That'll add nailing surface. So let's take a look at my mock-up here, which will give you even more insight into that. So here you see we have my exterior wall here, same exterior wall. Here is my 2x6 turned sideways. That is going to meet up with my 2x4 partition wall here. These get fastened together, and what you end up with, because your 2x6 is 2 inches wider than your 2x4, you end up with an inch of nailing surface on either side. Now we have a sturdy connection from top to bottom, and we also have added this really important inside corner nailing surface. This is not our only option for a T-wall connection. We can also do what is called ladder blocking.
Remember I talked about those scabs that are left over from your cuts? This is another option versus a 2x6 to fasten a wall where there's a void and nowhere to pin that wall to using your
I've got some of
scabs.
that on my model here. So what you see going on here is you have an exterior wall with a 2x4 T-wall connection to it. And what you see here are pieces of lumber that are run horizontally. They're about 2 feet spaced apart. They travel from one common stud to the next, and we can fasten this in.
So you can see on this side, the drywall has somewhere to pin. You've got this stud wall where we can pin the drywall to, but that wall coming through, there's nothing to pin to. So these double as well, it's called the ladder blocking as drywall on the opposite side, or let's look at it this corner right here. The drywall can be pinned there and on the ladder blocking as well. So you've got somewhere to tie that drywall into and somewhere to fasten this wall into along these blocks that you've put in. And what are these blocks? Your scabs that you have left over from your wall cuts.
Interior wall stud, this end stud, to any one of these ladder blocks. These also work as interior nailing surfaces for materials that we'll add like drywall. So whether we're talking about a ladder block T-connection or this nailer type T-connection, I would consider both of these energy efficient, like our California or 3-stud corner. Both of them offer access to this space back here to insulate later. That's a good thing. So all of
And that's it, guys. That's your framing 101, and specifically for interior framing of renovations and such. This is the way we do it. We had some terms in there, and you've got some practical on-site actual physical way of framing. And it wraps it up on this section of the course. We'll see you at the next section.